How's it going, everyone? We are talking about Canada and its greenhouse gas emissions. Canada has an election coming up, and one of the debated policies is what should Canada's policies towards greenhouse gas emissions be? The Liberal Party wants to maintain some constraints on greenhouse gas emissions, while the Conservatives want to lift those constraints. So in the context of that debate, it would be useful to know, well, what exactly is Canada's contribution to global greenhouse gas emissions? Where do those greenhouse gases come from, and what effect that could potentially have on Canada's economy? So let's get into that. We'll start our journey with Wikipedia, where there is a list of countries by their greenhouse gas emissions. So before we get to the table, we need to talk about some terms and explain the definition of those terms. So we have a list of sovereign states and territories by their greenhouse gas emissions due to certain forms of human activity. Okay, so we have the list, which looks at many different years, and these are estimates in kilotons of CO2 equivalent. Okay, now what is CO2 equivalent? Well, there's different types of greenhouse gases. About 80% of greenhouse gases, in terms of mass, are CO2. That's carbon dioxide. But carbon dioxide is not the only greenhouse gas. Now, why we care about greenhouse gas emissions is because of their potential to warm the atmosphere. So, when looking at a country's total greenhouse gas emissions, it's not enough to look at the total mass, because some greenhouse gases may theoretically have the potential to warm the atmosphere more than others. So the other gases are considered based on what equivalent amount of CO2 would theoretically have the same potential to warm the atmosphere. So, for example, here we're looking at the United States Environmental Protection Agency website. So for example, let's look at methane here. Okay, so methane is estimated to have a global warming potential, that's GWP, of 27 to 30. Okay, so what that means is that 1 ton of methane would have the same global warming potential as approximately 30 tons of CO2. So let's say a country emits 30 tons of CO2 and 1 ton of methane, their CO2 equivalent would be 60, because that 1 ton of methane counts as 30 CO2 equivalent, and the 30 tons of CO2 is 30 CO2 equivalent. Okay, so that's what they mean here when they're talking about kilotons of CO2 equivalent per year. Okay. Along with a list of calculated emissions per capita. Okay, so per capita means you're taking the kilotons of CO2 equivalent and dividing by the country's population. Okay, so if a country has a small population, then you're dividing by a smaller number, you end up with a bigger per capita figure, right? Assuming, same CO2 emissions, right? Or same CO2 equivalent emissions, right? If a country has a larger population, you're dividing by a larger number, and the result is smaller. So let's get to the table. Here we have greenhouse gas emissions by country/territory. All right, now here we have the emissions in different years for different countries, and it says kilotons CO2. Now above they said CO2 equivalent, so I'm assuming they mean CO2 equivalent here, even though they just wrote CO2. It's kind of sloppy, right? And here the title is not CO2 emissions, right? It's greenhouse gas emissions measured in kilotons CO2 per year, right? So probably they mean CO2 equivalent, right? But really they should write that when they're saying what the units are. So at the top we have China, United States, India, and if we scroll over to the third last column, percent of global total, we have 30% and 11.2%. and 7.8%, and you add those up, and that's approximately 50% of global emissions. All right, and if you scroll down further, you got in 10th place right here Canada, barely making the top 10. Look at that. I'm just going to get rid of the image of myself here for a second so you can see that it is in fact Canada in 10th place. So there we have China, United States, India, Russia, Brazil, Indonesia, Japan, Iran, Saudi Arabia, and there is Canada 10th place, right? So we scroll across and there we have it, 1.4% of the global total. 1.4%. Okay, so like the title says, Canada is not a major greenhouse gas emitter. They are responsible for 1.4% of the global total. All right, so if Canada were to cut its emissions in half, half of 1.4 is 0.7. Okay, that would be 0.7% of global emissions gone away, and the globe would still have to deal with 99.3% of global greenhouse gas emissions. So Canada is not a major contributor to global greenhouse gas emissions. So if Canada is not a major greenhouse gas emitter, why do many people think that it is? Well, there are a few reasons. One reason is that Canada makes the top 10. Humans naturally like to group things in groups of 10 and look at the top 10. Okay, sure, but what's so magical about the number 10? Why not top 9? Why not top 11, right? 10 is just an easy number to go by. The reality is you've got the top 3-4 emitters emitting about 50% of all emissions, and all the other countries are emitting a tiny, tiny bit, right? That's what the situation really is. The atmosphere doesn't care about your ranking in the top 10. It cares about the total amount of emissions, all right? The other thing is per capita, right? We talked about per capita. So there's Canada at 1.4. Its per capita emissions is 19.39, which you could see it's one of the bigger numbers on the screen, right? It's almost twice as big as China's, which is 11. It's bigger than the United States, which is 17, right? When people think greenhouse gas emissions, they naturally usually think of China and the United States. And those are the two largest emitters, right? And so when people hear something like, oh, you know, Canada's per capita emissions is more than that of China and the United States, people think, wow, Canada emits so much greenhouse gases. Okay, but again, this is per capita. Canada has a small population. You're dividing by a smaller number. The result is bigger. China and the United States have much larger populations, right? So you're dividing by a larger number. You get a smaller value. Look at India, right? Look how small their per capita value is, right? Because they have a huge population. So you're dividing their emissions, this number here actually, the 2023 emissions, and you're dividing that by India's huge population, you get a smaller number, right? Some argue that for a fair comparison, emissions should be analyzed in terms of the amount of CO2 and greenhouse gas per capita. So this is not correct, okay? You're saying for a fair comparison, emissions should be analyzed in terms of greenhouse gas emissions per capita. What is the purpose of the comparison? If the purpose of the comparison is to determine what effect a country's economy has on the atmosphere, well, the atmosphere doesn't care about the per capita figure. The atmosphere doesn't take the greenhouse gases emitted by a country, divide it by the population of that country, and then decide what to do with it. No, the atmosphere just absorbs the greenhouse gases emitted, whether it's emitted by one person or a million or a billion. Okay, so when the sentence is saying emissions should be analyzed in terms of the amount of CO2 and greenhouse gases per capita, or that some argue that it should be, what exactly do they mean? A fair comparison of what? Of effect on the atmosphere? No, it's not a fair or accurate comparison of effect on the atmosphere. Effect on the atmosphere is total emissions, not total emissions per capita. Okay, so what exactly are we comparing? Are we comparing how good morally a country is in terms of the righteousness of its people because of because you're averaging how much greenhouse gases are emitted per person. Okay, so if we have some morality scale based on greenhouse gas emissions, why are we basing some scale of morality off greenhouse gas emissions? Oh, because of how they affect the atmosphere. Okay, well then we're back to square one. The atmosphere isn't affected by the per capita number, it's affected by the total amount of CO2 emitted. So that doesn't work there. Okay, imagine a very small country with a very small population, but their entire economy is burning fossil fuels to generate electricity. And maybe they sell that electricity to others as well, right? So the total amount of greenhouse gas emissions as a percent of the global total for that country would be very small because it's a very small country, right, in terms of population. But their per capita gas emissions would be through the roof, right? Huge, because they have a small population. You're taking their entire economy, which is based entirely on burning fossil fuels, and dividing by their small populations, you're going to get a huge greenhouse gas emissions per capita. But that country emits a very, very small portion of total global greenhouse gas emissions, right? So per capita is not a useful indicator here. On top of that, right, if you're trying to estimate how much emissions are used per person served by those emissions, well, then dividing by a country's population also doesn't make sense because countries emit greenhouse gases to serve other countries as well. They emit those gases to provide goods and services to other countries. So if you really want to know on average how much greenhouse gas is used per person, well, then you shouldn't be dividing by a country's population. You should be dividing by the country's population plus all of the people that are serviced by the goods and services that come from that country emitting greenhouse gases, all the people who are from other countries, right? Because from trade, you have people who are not citizens of that country, but they're serviced by that country's greenhouse gas emissions. So per capita is a misleading figure. Now, if we dig deeper into this and ask, okay, well, where exactly do Canada's emissions come from, this 1.4% of the global total? And when we dig into that, we actually see that Canada is an even cleaner country than this number makes it look. All right. So above this chart, we have a reference. Okay. The data in the following table is extracted from something, right? And Wikipedia does provide references pretty often, right? So you can see where the numbers come from. And clicking this link takes you to this website here, greenhouse gas emissions of all world countries. And if you scroll down, there is this file here, greenhouse gas emissions of all world countries. And that file looks like this. Okay. So it has many pages for, a page for each country and some summaries and all that, right? So if we look at Canada, we see actually where its emissions come from, right? So where do greenhouse gas emissions come from? You've got the power industry, which is generating electricity. You've got industrial combustion and processes, so factories. You have buildings, transportation, right? Heating, air conditioning, gas, cars driving around. Fuel exploitation, so extracting natural resources for the purpose of fuel. You've got agriculture and you've got waste, okay? So here you have 2023. The amount of each color represents what portion of the total amount comes from that part of industry. And look at the yellow. Power industry, yellow, is a very small portion of Canada's total emissions. Now, why is that important? Okay, that is important because power industry is where you can make big changes in terms of greenhouse gas emissions. All right, because there's different ways to produce electricity, and some ways emit a whole lot of greenhouse gases, like coal power plants. And on the other side of the spectrum, you have nuclear, which generates a tremendous amount of electricity with very minimal greenhouse gas emission. For every single source of generating electricity, there is some greenhouse gas emissions, okay, including stuff like wind and solar, because you have to manufacture the solar panels and the wind turbines, right? Then you have to drive them to the location, then you have to dispose of them once they're worn down, right? So there's some greenhouse gas emissions for all forms of power production, but for so-called like green energy, the actual direct moment and process of generating the electricity, that doesn't emit greenhouse gases. Okay, so power industry is where you can make big changes, and that is a very small portion of Canada's emissions because Canada's power grid is actually very clean. Okay, now let's compare that to some of the other countries in the top 3. Okay, so we've got China. Look how big that yellow bar is, right? It's almost half of their emissions is from the power industry. That's because of a lot of coal power in China. If we look at United States, there we go. Okay, again, you see how much bigger that yellow bar is compared to what it was in Canada, right? We also had India there. There we go, India. Okay, so again, you see the size of that yellow bar. Okay, much larger portion of the total than what we saw for Canada. And we had Russia was 4th place. There we go. Okay, larger yellow bar. And now Russia's per capita value is actually pretty close to Canada's, right? And then, okay, let's go back to Canada to remind us what that looked like. There we go. Okay, look how tiny that yellow bar is. All right, so let's dive in and see how Canada produces its electricity, and then we see why that yellow bar is so tiny. Okay, here we have electricity generation by fuel type from 2021. Okay, this is from the Canada Energy Regulator website. Okay, and we have the percentages here. So 60%, and this wouldn't have changed that much since 2021, 60% is hydro, and then we have 14% is uranium, which means nuclear. All right, so and then we have where is it? Wind. It is the purple one, which is 6%. Okay, 60 plus 14 plus 6 is 80%, and then we have a little bit of solar as well there, right? So more than 80% of Canada's electrical generation is green energy, is clean energy. Okay, we've got lots and lots of hydro, you've got nuclear, you've got wind, you've got a little bit of solar. More than 80% of Canada's power production, clean energy, right? That's why that yellow bar over, where was it? Here is so small. We can ask, okay, well, there's still natural gas here, 12%. There's a bit of coal here, 5%. Okay, if Canada is so clean, why does it still use fossil fuels? Well, the fact is, in most places, the way electricity production works, the way electricity consumption works, you need a little bit of fossil fuel fueling your electrical grid in most places. And to explain why, I'm going to go to some slideshows here. So let's do that. Okay, so electricity production needs to meet the demand, okay, because we don't really have a good way of storing electricity, right, technologically, right? Our battery technology is just not that advanced. I don't mean Canada's, I mean the world's. So power demand fluctuates, and so power production also has to fluctuate over the course of days, weeks, months, and so on, right? So when you're producing power, you have to produce that baseline, which is the minimum amount, okay, that's the base load, but then you have to produce fluctuating amounts of power to meet that fluctuating demand. And the fact is, different methods of generating electricity have different capabilities in terms of those fluctuations. Okay, so you've got nuclear, which does not emit greenhouse gases during operation. It doesn't depend on the geography of a country that much. Okay, a little bit it does, but not too much. Not like something like hydro, and it produces enough electricity, it's efficient enough that it could satisfy the base load, but it cannot fluctuate its power output, okay? That's the big weakness of nuclear. It cannot fluctuate power output. So it can produce that base load, okay, right here up to here, but it can't do those fluctuations. For that, you need something else. Okay, so what's the something else? Well, you've got solar, you've got wind, you've got hydro. The problem is that they depend on geography. All right, you need the rivers for hydro, you need enough wind for wind, you need enough sun for solar. And although they also don't emit greenhouse gases during operation, what happens if the demand exceeds what you can produce with nuclear, solar, wind, and hydro? Okay, for those situations, for those days, for those hours, you need some way of producing electricity which is independent of geography. Okay, where you can just put in as much fuel as you need, turn it on, produce the power that you need. Once you don't need it anymore, fluctuate it down or turn it off easily. And this is where the fossil fuels come in, coal and natural gas. Okay, they can fluctuate power output and they're geography independent. Now, why coal is highlighted here is because coal is also, it's available in many locations underground, right? So that makes it even more convenient than natural gas. So it produces the most greenhouse gas emissions, okay, but it is convenient for these other reasons. And that's why, because you need to meet those fluctuations, in most places, a energy grid has a little bit of fossil fuel production. Okay, so if we go to the next slide here, this is like what an ideal grid would look like, right? So you have your nuclear producing up to your base load, and then for the fluctuations, you have your renewables. Okay, you have your wind, your solar, you can have your hydro there as well if you have the rivers for it. That's producing as much as it can to meet the fluctuating demand, and when there's a little bit of more demand than what renewables can give you, then you turn on those fossil fuel plants and produce what's left. So if we go back to what Canada looks like, we see that it does have a bit of fossil fuel, right? You got 12% natural gas, 5% coal, and that just makes sense, right? A little bit of fossil fuel is there, but notice that the large majority of that fossil fuel, 12 out of 17% that it makes up, 12 out of 17% is natural gas, which is substantially cleaner than coal. Okay, so Canada's electricity grid, okay, 80% clean energy and more than 80% clean energy. And of the 17% that's fossil fuel, which is understandable, a little bit of fossil fuel is there, most of that is 12 of that 17 is natural gas, which is the cleaner fossil fuel compared to coal. So Canada has a very clean power production industry. The rest of Canada's greenhouse gas emissions come from just parts of the economy like agriculture, buildings, transportation, factories, right, fuel. So that's stuff that's difficult to change, right? Unlike power industry, which again is quite clean, and all of those emissions together account for, as we've seen, for Canada, 1.4% of the global total. So there we have it. Canada is quite a clean country in terms of greenhouse gas emissions. It is not a major greenhouse gas emitter on the world stage. So I hope you enjoyed that, and until next time.